Hello everyone. Our project is Analytics for Hospital Healthcare Data. Our project is worked for IBM Nalethiran conducted by Tamil Nadu government. Our team ID is PNT 2022 MID 01342 presented by Adithya R, Lingeshwaran C, Mohanraj V, Charan K.
Analytics for hospital healthcare data. Data analytics is the process of examining raw data set to find trends, draw conclusion and identify the potential for improvement. Healthcare analytics uses current and historical data to gain insights, macro and micro, and support decision making at both the patient and business level. Healthcare analytics refers to the use of vast amount of collected data to provide organization with actionable insights. These insights are developed through analytical discipline to drive fact-based decision making. In turn, these decisions improve planning, management, measurement, and learning. As healthcare organizations around the world are challenged to reduce cost, improve coordination with care teams, and focus on improving patient care, analytics will be especially important. Building analytics competencies can help healthcare organizations harness big data to create actionable insights that can be used by healthcare providers, hospitals, and patients. The use of healthcare data analytics allows for improvement to patient care, faster and more accurate diagnosis, preventive measures, personalized treatment, and more informed decision making. At the business level, it can be lower costs, simplify internal operation, and more.
Analytic story. Moving to the first visualization in the analytic story. The first visualization is about the severity of illness reported by case ID. Severity of illness is nothing but the severity recorded at the time of admission. Case ID is nothing but the ID given to the patient at the time of admission. From this plot, the severity of illness from the total cases can be inferred. The severity of illness can be classified into extreme, moderate, and minor. The highest number of cases reported tends to be moderate and accounts for about 1,73,425. The next after the moderate comes the minor in terms of the cases reported and accounts for about 84,319. And the extreme cases account for about 56,049, which is the least when compared to the minor and moderate in terms of severity of illness reported. Moving on to the next slide. The next visualization is about the availability of extra rooms in the hospital depending on the hospital type code. Hospital type code is nothing but the unique code given to the hospital depending upon the type. The hospital type code can be categorized into A, B, C, D, E, F, and finally G. This plot can be used to get insight on the availability of beds in each hospital using the hospital type code. From this we can see that A has the highest availability of extra beds, extra rooms, followed by B, C, E, D, F, and G. G has the lowest number of extra rooms when compared to the others using the hospital type code. Moving on to the next visualization. The next visualization is about the cases reported in different age groups. This graph gives us the clear picture of the number of cases reported in the different age groups. If we take a look into the graph, we can clearly understand that the age group 31 to 40 is where the most of the cases have been reported, followed by 41 to 50. The age group 91 to 100 is where the least number of cases have been reported, followed by 0 to 10, which is the next least number of cases reported. The next visualization is about the stay by patients. From this graph, we can infer that most of the patients have stayed for a period of 21 to 30 days, and the next highest is the period of 11 to 20 days. The lowest number of days occupied by the patients ranges between 91 to 100, followed by 61 to 70. Moving on to the next visualization. The next visualization is about the total admission deposit collected depending on the stay. As we have seen in the previous visualization that most of the patients have stayed for a period of 21 to 30 days, followed by 11 to 20 days. So these two have majorly contributed to the admission deposit collection for the hospitals, followed by 31 to 40 days, which is the next highest admission deposit collection to the hospitals, as most of the patients have stayed in these periods. Moving on to the next visualization. The next visualization is about the visitors with patients depending on the hospital type. From this graph, we can infer that type A has the highest number of visitors with patient, followed by type B, which has the highest number of visitors with patient, followed by C, E, D, F, and finally G. The G has the lowest number of visitors with patients. The next visualization is about the patients reported in the hospital region code. The hospital region code is nothing but the region code of the hospital. The hospital region code can be categorized into X, Y, and Z. If we take a look into the plot, we can clearly understand that the hospital present in the region X have reported the highest number of cases when compared to Y and Z. The next after the X is the Y, which has reported the next highest number of cases. The hospitals present in the region Z have accounted the lowest number of cases reported. Now moving on to the analytic report.
As we move on to our next slide, we are going to see a report on the hospital analysis healthcare data. Initially, we have two charts, and one is a pie chart and another one is a line chart. If we see, we can clearly observe that we are analyzing our patient's admission deposit on the type of admission. If we look into type of admission, we have three types of admission. One is emergency, trauma, and urgent. Depending upon the patient's admission, we are classifying them into three categories. Either they are in an emergency ward or in a trauma ward, or they are in an urgent ward. And then if we closely see the right hand side, we can use to see there is a admission of patient in various departments. We have four types of departments: radiotherapy, anesthesia, gynecology, and TB disease. In these four departments, we can infer that type of admission, how much patients that they have been getting admitted each day. After we see that, we move on to the next slide. It's based on the available extra beds on the hospital. In the left hand side, we used to see a scatter plot in where we can infer the information of available extra beds in each hospital. We have a hospital code for every hospital. From that, we can infer that how much available extra beds have been available in each hospital. And the right hand side, we can see the patient reported in each hospital. It's a type count of the patient. Depending upon the hospital, how many patients they have been accounted into it. After move on to our next one, is next one based on a admission deposit and bed grade. In the left hand side, we can see the graph displaying admission deposit for various departments. Just like I said previous, we have four departments: TB disease, radiotherapy, gynecology, anesthesia department. From that four departments, we can infer that how many amount of or how much admission deposit have been deposited in these departments, how many patients have been getting admitted into these departments. And then in the right hand side, we can see the bed grade to the ward facilities. In ward facilities, we have types of ward: F, E, D, B, and A. There are six types of ward facilities. And in bed grade is the type of the bed. It is classified into 1, 2, 3. The three grades, 3, 4, and 4 grades of bed grade. In that ward facilities, how many wards are having the type of bed grade? We can infer that information from this chart. And next one is available of extra rooms in hospital region code and the type code. We in our data, we have hospital type code for each and every hospital. It's an unique type code for every hospital. In that, we can infer that how many extra or how many extra rooms have been available in these departments. And from the left hand side, we can see we can identify two types. From that, we can get how many available rooms in hospital region code. And then in the right hand side, we can get the information by obtaining the hospital type code. Thank you.
Analytical dashboard. In this visualization, we see case ID with ages. The x-axis consists of age and y-axis consists of case IDs. If we look at the graph, we can clearly understood that Age group between 31 to 40 consists of most patients have been reported. Moving on to the next slide. In this, severity of illness being reported, and it is classified into three types: minor, moderate, extreme. Extreme consists of less patients and moderate consists of high. Patient with visitor in different hospital consist of more visitors and G is less. In between B2Fs or moderate. Based on the shades of colors it differentiated. Moving on to the next slide. Hospital code. Hospital type, code, region have been tabulated. Most of the hospital in X region and less in Y region and moderate in Z region. Based on the city code hospital by hospital region code, X-axis consists of 5 regions, Y-axis consists of 2 regions and Z-axis consists of 4 regions. Moving on to the next visualization. There are two tables, what types and what facilities have compared with the bed gates. We have clearly understood that F consists of more facilitated and A consists of less facilitated. What facility code by what type? P, Q, R, S, T, U are the what types. Q or S have what facility code 6, P have what facility code 5, T, U have what facility code 6. Moving on to the next visualization. In this slide, visitors with patients for departments. There is more departments like radiotherapy, gynecology, surgery have been measured. Gynecology consists of more patients and surgery consists of less patients. Finally, value is summed. In this table, department and visitors with patients are in ascending orders from surgery to gynecology. The value have been arranged. Surgery consists of 1704 and gynecology consists of 346,316 number of patients. Moving on to the next slide. Case ID by what facility code. In this visualization, it have segregated layer by layer. F consists of 35.5% and A consists of 9.0%. B and C consists of same value 10.9%. Finally, it have been segregated and the value have been shaded with some colors. Watt facility code. It consists of 6 watts, named it as A, B, C, D, E, F. And moving on to the next slide. Case ID by watt type. In this visualization, it represented in column-oriented bar chart. R consists of more cases, 54,113, and U consists of less case IDs 2. Watt type. It consists of 6 watts, named it as P, Q, R, S, T, U. And moving on to the next slide. In this visualization, we know about patient ID by age colored by departments. Pink is for TB and chest diseases, orange is for anesthesia, blue is for gynecology, purple is for radiotherapy, red is for surgery. Age group is 41 to 50 are highly affected and mostly in gynecology. Thank you.
Here is the final view of the web page.